Let us discuss about how you can apply the Pythagoras theorem to solve distance problems. However, in this problem that we are going to discuss, you may need to go more than one stage applying the Pythagoras theorem until you come to the required answer. So look at this figure here. You have this right angled triangle here, and you have this right angled triangle here. Suppose this is a sketched diagram from this concept here. Suppose someone is somewhere here on top of an elevated area or on a platform, and this person is looking at two objects, maybe one object here and another object here. In this case, the objects that are being observed is a stone and an orange. So the line of sight, the line of sight from the observer's eye to the first object will be here, and this other line of sight from the observer's eye to the second object will be here. So this angle here will be 90 degrees, like it is here. So this is the observer's eye, and this is the position of the first object, which is a stone, and this is the position of the second object which is being observed, which is an orange. Now, the distance from the bottom of the platform where this observer is to the stone, the horizontal distance is 5 meters. And the distance from between the two objects is 7 meters. The distance from the observer's eye to the first object, which is stone, which is being observed, is 10 meters. So the question is, what is the distance from the observer to the second object which is being observed, positioned here? In this case, the object is an orange. So in order to work out this distance here, you may need to sketch again this figure, and then you label it. In this case, if we sketch again this figure, we'll get a figure like this. This angle is 90, and in this case, this will be 5 meters, 7 meters. This is, we may call this A, this point B, this C, and this D. This distance here is known, 10 meters. Okay, we want to find this distance here. We may call it AB. How do we find it? Obviously, we cannot apply the Pythagoras theorem directly here, because to apply the Pythagoras theorem, you need to have at least two sides of a given right triangle. But in this case, you have this distance, which is 12 meters. 7 plus 5 meters makes 12 meters. But you don't have this, and either you don't have this, so you cannot apply this triangle first. So you need to find this distance first, and then once you find this, then it is where you can apply this side and this side to get this side. So let us begin with the smaller triangle to get distance AD. So consider triangle ACD. If you sketch the triangle, it is like this. This is A, and this is C, this is D. This is 5 meters, and this is 10 meters. So how do we get AD? You apply the Pythagoras, that is CD square plus AD square equals to AC square. CD is 5, and AD is 10. AD, you don't have AD, this remains to be AD square equals to AC, which is 10 meters. This gives you 25 plus AD square equals to 100. AD square will be equals to 100, then you less 25. You remain with AD square equals to 75. And then you square both sides, this and this cancels, you remain with AD equals to 25 square meters. So now you have AD. This distance here is now known to be square root of 75. So again, you consider the bigger triangle now, which you may call it triangle ABD. If you sketch the triangle, it will be this way. If you sketch it, it will be this way. This is A, and this is B, this is D. The distance from here to here is 12 meters. And this distance AD, you calculated it, and you got it as 75 meters. So to get BA, which was actually the required distance, you apply again the Pythagoras theorem, in which you take the sum of the squares of the two adjacent sides to be equal to the square of the hypotenuse side. So the first adjacent side, BC, is 12 plus 75 square root. This equals to AB square. So this is 144 plus 75 equals to AB square. If you add these two, you get 9 here. That is 4 plus 5, and this will give you 11. And then this will be 2. So you have 219 equals to AB square. Then you square on both sides. This and this cancels. You end up getting AB equals to 219. That is 219 square root. And these are meters. Remember, AB is this distance here, which was actually the distance of the observer's eye to the orange. So this discussion was focusing on the way you can apply the Pythagoras theorem to solve distance problems, whereby you are required to use the Pythagoras theorem in stages so that you come up with the final answer.